A tank contains 1,000 liters of pure water. Brine that contains 0.05 kilogram of salt per liter of water enter the tank at a rate of 5 liters per minute. Okay, and then brine that contains 0.04 kilogram of salt per liter enter the tank at a rate of 10 liters per minute. The solution is kept thoroughly mixed and drains from the tank at a rate of 15 liters per minute. How much salt is in the tank after 30 minutes and after 1 hour? Okay, so let's write out what is given by the problem here. So we have some brine here, which 0.05 kilogram salt per liter, right? And then it enters the tank at a rate of 5 liters per minute. So we have 5 liters per minute. And then the second flow here, we will have 0.04 kilogram per liter. Okay, and then it enters with the rate of 10 liters per minute. Okay, and then it goes out at the rate of 15 liters per minute. Okay, 15 liters per minute. And then this tank here contains 1,000 liters of water. Okay, and then let the salt here is X kilogram. So salt here is equal to X kilogram. So we have the concentration of salt here in the tank is X over 1,000 kilogram, right? So let's write that concentration of salt in the solution. Of salt in the tank, that will be X kilogram divided by 1,000 liters. So I will have kilogram per liter here. Okay, and then the rate of the change of this salt in the tank here will be our dx dt, right? And logically it will be increasing, right? Because this one here contains salt and initially it is pure water. So we'll have pure water here. What does that mean? That means that we will have x0 is equal to 0 kilogram. That is the initial condition. But for the rate of the change of the salt, we need to sum out what is the rate of the salt in, and then minus rate of the salt out. Good. And then we have 2 flows of salt goes in, right? So we will have this one here, 5 liters per minute, and this one will be 0.05 kilogram per liter. Or we can multiply them. So I will have 0.05 multiplied by 5. The unit is in kilogram per minute, right? So this one will be in kilogram per minute. But I don't write that for simplicity. And then we will have this one here. So I have plus. We will have 0.04 multiplied by 10 liters per minute, right? And then the salt that goes out, we will have 15 liters per minute. So we will have minus. But then we have x over 1,000 kilogram per liter. So we have x over 1,000. Then multiplied by 15 liters per minute. Good. And this will be our differential equation. Let's simplify this thing. So I have dx over dt here is equal to 0.25 and then plus 0.4 and then minus 15x over 1,000. Okay, and I think I will multiply this here by 1,000 to get rid of all the decimal and this denominator here. So I'll have 1,000 here, and then dx dt, and then we will have 0.65 multiplied by 1000, so I will have 650, and then minus 15x. Good. And I think we can work with this, right? Okay, so let's clean up our slide and work with the differential equation. Okay, this is separable differential equation. Let's put the dx here. So I'll have dx over 650 minus 15x on the left hand side. And then on the right hand side here, I will have dt over 1000. And we can integrate both sides, right? So here on the left hand side, we will have minus 1 over 15 natural log here of 650 minus 15x. Good. And then on the right hand side, I will have t over 1000. Okay, and then all of that is added by c here. Good. Now let's multiply both sides here by minus 15. Okay, so we will have natural log here of 650 and then minus 15x, and then we will have minus 15 divided by 1000 t, and then a constant multiplied by minus 15, that will be another constant. So let's just name this as constant number 2. Good. Okay, let's continue this after cleaning up the slide. Okay, so now let's exponentiate both of sides and the length will go. So I have 650 minus 15x, and then we will have e to the minus 15t over 1000, and then plus some constant c2, or I can rewrite this as e to the c2, but e to the c2 is just another constant, right? So we'll have 650 minus 15x, and that will equal to some constant. I will name it a, e to the minus 15t over 1000. Good. Now let's move this one here. Let's isolate for x. 15x here is equal to 650, and then minus a e to the minus 15t divided by 1000. Good. Let's divide both sides by 15. So I will have x, and we will have 650, and then minus, no, divided by 15. That will be, what is it? 650 over 15, and then minus a divided by 15. That will be another constant. Let's name this as b. So I'll have e to the minus 15 t over 1000. Okay, so now we have x0 is equal to 0. Let's plug that into the equation. X0 is equal to 0. So we will have this one here, 650 over 15, and then minus b, e to the, this will become 0. So I will have e to the 0, and that will equal to 0. But e to the 0 is 1. So this one is equal to 1. And so we can isolate for b here. So here we will have b, that will be 650 over 15. And we can just plug this b into this formula here. Okay, let's clean this up. Okay, cleaning this up and plug in the b, we will get the answer of question A. xt here is equal to 650 over 15, and then minus 650 over 15, and then e to the minus 15t over 1000. I think you can simplify this, but I will leave it as is. Okay, so for the question B, we will have the salt after 1 hour here, so I will have x on the 60. And then we will have 650 divided by 15 minus 650 over 15 e to the minus 15t over 1000. And t here is replaced by 60, right? So we'll have 15 multiplied by 60 divided by 1000. Good. And now we will have that one here. Let's calculate that. 650 over 15, and then minus, we will have that again, 650 over 15, and then e, so e, and then minus a fraction here, 15 times 60 divided by 1000. Okay, I will have 25.71. 25.71, and the unit here will be in kilogram. Okay, hopefully I did not make any mistakes during my calculation. Thank you for watching. See you in the next video. Bye bye.